Welcome. It's now time for the webinar with KMC Controls. And our topic for today is hardening critical infrastructure to decrease operational technology cyber vulnerabilities, or OT cyber vulnerabilities, and to minimize potential for harmful impact to personnel, building systems, and the environment. And it's truly a pleasure being part of this, and more so an honor. I'm going to let the guests introduce themselves, or the panelists introduce themselves in a moment, but we have Sandy Kline, we have Lewis Parks, and Paris Stringfellow. And I know them, and I am thrilled, I'm inspired by what each of them has accomplished and what they bring and what they see in the future. And I do hope that each of you will enjoy this. Now, just a matter of housekeeping. First of all, as you have questions, bring them up in the chat session, and we'll do our very best collectively. And we have some backstop behind the scenes to monitor those. The other thing to keep in mind is at the very end, I'll try to make sure to open the floor up, maybe 5 minutes out, and be agile, and also kind of close things out. And for example, we do this every month. We change the topics. So our next webinar will be on Friday, April 18th, also at 1 p.m. Central, or 1 p.m. Eastern time. So I guess with that, I want to go around the table, and I think I'd like to start on the order it appears on my spreadsheet. So Sandy, could you kindly introduce yourself, a little bit of your history, and a little bit what you're doing now, and then we'll move on to Paris, then to Lewis.
Got it. Good afternoon, everyone. Sandra Kline. So I currently work for the Department of Defense, running the department's installation cybersecurity resilience program, which is really focused on the cybersecurity challenges of what people refer to as operational technology or control systems, and specifically the vast variety, diverse kinds of control systems that you'd find on a military installation, which is very similar if you were a campus or a city or a community. We're trying to look at how do we cyber harden energy and water, HVAC systems, but also things like transportation systems, rail systems, airfield and port ops. So relatively new job created in DoD in recognition that all of the solutions that work for IT cybersecurity really just can't be sort of like applied directly to the control systems community. Prior to that, I've worked for a number of decades in a lot of different jobs within the Department of Navy in the areas of logistics and strategic planning and business process and reengineering, and running the Navy's military construction program and some of the cybersecurity programs, and then spent 5 years at the Assistant Secretary of the Navy level, working on installation resilience broadly, but with energy, water resilience, climate resilience, and an area that we call mission assurance, which I'll talk a little bit more about, but that's really what are the things that have to be in place on the installation so that the mission can be accomplished, that the mission can be assured. I'll stop there.
Perfect. Thank you so much. I think you all will learn why I'm so inspired by Sandy in particular, and all of the panelists. So Paris, please.
Sure. Thanks, Ari. Hi, everyone. Good afternoon. Paris Stringfellow here, and I currently work for a company, Practical Fusion Solutions. We focus on communications for technical environments and for scientists. And so that's what I do today, but I had the pleasure of getting to know Ari and Lewis, Mr. Parks, actually, through my previous life as a director for sustainability for an organization called CyMani. And so that's the Cybersecurity Manufacturing Innovation Institute. It's a manufacturing innovation institute under the Department of NIST, Manufacturing USA network, if you're familiar with that. And that institute and the work we did there, and why I'm so passionate about this topic today, really looked at how we as a country can can start to rethink how we embed cybersecurity into our IT/OT systems, including the built environment, and specifically in this case, manufacturing. And so the Institute and the work that I've spent the past 5 or 6 years on focused on not just cybersecurity layering, right, like add-ons, but how do we embed cybersecurity at the beginning of our designs? And so anyway, that's the work that I did and what I hope to share with you today. I have a background in engineering, systems engineering, spent a couple years cutting my teeth in nuclear engineering. So I did nuclear main control room design and eventually found my way into risk and risk mitigation. So that's my background, and I'm excited to be here.
Amazing, amazing, and not even 30 years old. So, all right.
I wish. Thank you.
Lewis, Mr. Parks, Professor.
I'm not even sure I want to introduce myself at this point. So, anyways, Paris, good to see you again. Sandy, great to meet you. Ari, thanks for having me. So I'm Lewis Parks, co-founder and CEO of a company called Retrofitting. With my partners, we've been focused in the cybersecurity space and the challenges of securing very small processors at the edge of a network, which brought us to develop a product called Dome. With our partners Intel, and very, very specifically, we have been focused in the OT space, so not the IT space. And Sandy, thank you for your detailed introduction. It was kind of almost a setup for us because there's been decades and decades of tools, and particularly network-based tools, that are very, very good for the IT world that have come into the OT world, which is good. You want to always have security, but there are some very specific things, which I think we'll probably get into today, about OT cybersecurity that make it unique and specific on how you secure it. And related to the commercial world, we've participated in ISO standardization committees, NIST, ETSI, which is a European Telecommunications Standards Institute. That's the European ETSI, and the only good reason, well, there's many reasons to participate, including the fact that all their meetings are held on the French Riviera. Anybody out there needs to join a standards group, etc. So we come to this world both from the practical, from the highly technical, and then also from the application and standard side. Take it away.
Thank you. So as we shift now to the next part of the webinar, we'll go around. At first, I'll call on you specifically. So Paris, just kind of heads up, I'm going to call on you first. And then there'll be questions posed either by me or by someone in the audience, and we'll just kind of figure out, you guys amongst yourselves will figure out who to field it. But Paris, I'd like to start with a question. And given your background, I think this will be easy peasy. But from your point of view, through your lens, what is critical infrastructure?
Sure. I that's a great place to start. And, you know, it's something that engineers and resilience, I think, have been dealing with for a long time now. And the way I always thought about critical infrastructure is, you know, especially as we think from the nation, right? What is critical infrastructure to the nation? It's those systems that we need as a society to function as a society. And so, you know, critical infrastructure in the broadest sense can be anything from, you know, gas and energy and water and wastewater, all the way to school systems and police departments and hospital systems. So, you know, that is, I think, a very connective theme through all of this. As we think about risk mitigation, we have to first understand, you know, what is it we need to operate as a healthy and successful society. And so at a very broadest sense, to me, it's those things. And I think certainly there are some specific definitions around exactly what it is.
I appreciate that. So next, Sandy, I think, again, you'll find this easy, but if you put on your lens and kind of filter a little bit what Paris said, but wear your DoD hat, what are, you know, obviously be speaking as general as you need to speak, but what are examples under DoD of critical infrastructure? What are some buckets or categories?
Gotcha. So that's a great question, because you'd think like in DoD, we'd have a definition and everybody would agree. But I can tell you from working with the installation community and trying to focus limited resources in terms of critical infrastructure, whether it's to respond to extreme weather or energy resilience, there's a lot of disagreement about what is critical infrastructure on a military base. And so if you're the public works officer who's responsible for making sure everything's working on the base, critical infrastructure is probably the commanding officer's house, because when he calls, you need to respond. But that would not be sort of the pure DoD definition. And so DoD actually has defined critical infrastructure in two different ways. It used to be defined based on mission. So you would have an operations plan or a mission, and then you would do what we call mission decomposition and go from the top of the mission, if it's a ship or a sub, what are all the things that need to be in place for it to be able to perform its mission in a conflict? And so there could be training, there could be fueling, there could be spare parts, and there could be critical infrastructure. And so that's one definition. And then there's a more recent definition coming after 9/11, where we also looked at like single points of failure. And so there's also a definition of defense critical assets, if you will. And those are the things that are one of ones. And so it's not just for a specific mission, but this is a one of one thing that if it fails, impacts multiple missions. And so that's sort of our top priority. That's the crown jewels that we look at first when we're talking about critical infrastructure, and then expand the aperture to broader mission accomplishment. But it used to be that our installations, the critical infrastructure was important, but we were going to fight a conflict somewhere else. We were going to go fight far away. And so, infrastructure on our military bases, while it was important, it didn't play the same role that the infrastructure on our military bases are today. So, example, Air Force. Air Force is fighting wars from Air Force bases in the US. And that wasn't always the case. And so it changes really the dynamic of what's happening on our bases. And then secondly, the critical infrastructure is important because the homeland is no longer a sanctuary. That's a statement that's been around for a number of years in the defense strategy. And so again, this idea that people are trying to attack infrastructure on our bases, and if we can only harden some of it, what's the most critical, really makes this discussion of what is critical infrastructure and who decides a really powerful and important discussion.
That's a perfect lead up for you, Lewis, but I want to do it in maybe a two-step way, because I want to riff off both of the inputs from Paris and Sandy, respectively. So you're a world traveler and you see a lot. So my first, part A of my question to you, Lewis, is do you see a little bit difference about how we define this in the US versus, for example, in South France on the Riviera during your event? Or other parts? I know you're born in Canada, so you have a Canadian perspective and speak French. And so part A is there a delta between the perspectives on what's critical infrastructure? Yes or no? And if there is, what is it? And part B, then we'll get into the hardening, but let's just focus on part A.
So I think part A is that there is arguably no difference, and it's pretty surprising. A few years ago, I was fortunate enough to attend the opening of a new Intel Center of Excellence in the middle of China. I flew to, I think it was Shanghai, and then flew another 4 hours into the center of the country to a city I never heard of that had 30 million people in it. Typical China visit.
Probably Chongqing.
It's where it was. Good guess. Anyways, the president of Intel China brought the mayor of the city by, and this is a significant industrial city. You do not want to breathe their air for long. Wonderful people. And in seeing a demonstration of our technology, again, protecting cybersecurity infrastructure, immediately said, we need this. Now, that was very kind and generous, but the point simply being that the need for critical infrastructure protection, I think, translates geographically, economically, politically, everywhere in the world. We are as active looking at a project in the Middle East next week, as I just returned from the west coast of the US yesterday. So I think it's critical. I think the other thing, and this is again to both Paris and Sandy's points about what defining critical infrastructure, how that's evolved. The introduction and what a network is today and the extensibility of a network and what a network controls, whether it's water or lights or heat, is so much so to the point there really isn't a border. This becomes almost a borderless situation. And that's what you're protecting against. So you don't think about the water supply on an air base in the US when you're discussing what the attack plans are, perhaps in another part of the world. And yet at the same time, you need to be protecting that too for a variety of reasons. So, I guess the summary is the landscape is broad. There's a lot of commonality, etc. And fortunately, nobody's ever successfully attacked a restaurant we've been in the French Riviera. So far, so good.
All right. So here's part B. There is some anonymous base, doesn't matter what military service, with all respect to the DoD, but there is some base that for whatever reason, it's a priority, a high priority, and it's been defined appropriately as critical infrastructure. And so when you think about the different systems in the different buildings on that campus, let's just say it's it's a mile by a mile. So not small, but not big, but pretty big. So a mile by a mile, it has its own roads, it has its own, substations and all these other things that make it self-sustaining. When you think about that, Lewis, what are some best practices that kind of warming us up into the core of this topic? How do you harden that base? And in particular from some cyber attack on the OT?
Well, in the old days, the easy way to do that was just simply to use a term, air gap everything. Don't connect it to anything and let it run independently. And of course, you can't operate commercially or militarily in a disconnected world anymore. So on the premise you're connected, you need to be doing all the things that you hear from the corporate sector, from your firewalls and your VPNs and multi-factor authentications and what have you. What's equally important, this is where it begins to get difficult when you talk about an OT world. And by the way, I will tell you this is a weakness in some situations now, and that is we take a lot of our IT practices to apply it to the OT world. So again, in a office or business setting, it may be easy to segment the network based on different functions and areas, so that if there is something seen in the HR department, we can take that server offline. It becomes a lot harder if you're segmenting a portion of a base that is in an operational situation and needing to disconnect it from other critical elements of the base. So some of the tools that you would typically use become hard to implement, even though, again, you will want all the typical cyber monitoring, all the network monitoring, all of the incident reporting technologies, again, that exist in the commercial world. And then finally, you will likely, and again, in their situation, have a lot of failover and backup components, probably more critical than getting, Amazon's website back up in time for my wife to get home and buy something or for me to buy something. So, these are all the standard tools that have come across from network technology. But again, the focus isn't so much on, the visibility and creating a response. It's really, you want to maintain operational capability. And that becomes the challenge point. So in our particular case, we've focused at the device level at the edge of a network for providing protection. And there are other things that people should do. So again,
I want you to go into that in a second.
Yeah.
Actually on this part B, and then I want to quickly riff to Sandy and to Paris. But because Lewis, what we want to do is prevent the attack from occurring. I think it's great that you can monitor that something's occurred, but how do you prevent it on some edge device X, like a thermostat or whatever edge device you can think of?
I mean, the optimum way to do it is to either have embedded technology in it, similar to all those devices I buy at Best Buy that can't join my network unless I correctly bring them on board. And unfortunately, in the industrial world, that typically is not the case because, we're also struggling with the fact that all these systems we've named that are needed to run a base or run an operation all don't run on Apple or all don't run on Windows. There are in some cases no OS to standardize on. So I think that to the extent possible that these devices can contain it is a good thing. There are also gateway appliances. We do one. There may be others that actually put up a cryptographic or a security fence in front of an installed device. And that is also part of the challenge that there are tens or hundreds of thousands of buildings in DoD and millions of systems and billions of endpoints. And you can't replace them all, at least not in the current budget environment yet. So the challenge is how do you protect them? And I think that, edge to your point, edge point protection is the best you can do. And going all the way back to the other end is monitoring and watching them, which is good, but not effective in stopping.
I actually think that, no offense, Paris, I think actually I want to go to Sandy because this is what Sandy's living. So Sandy, could you expand, like what are some best practices, again, without referencing anything that might be sensitive, to harden some base,
Right. I mean, interestingly enough, as we've been talking with the services and with industry on some zero trust for OT that we've been working on, there was an overriding sense that the thing that people continue to see, and this really shocked me, is that we still have physical security lapses. So we still have, the rooms that have, the access to energy and water control panels are like not locked, not secured. And so I just throw that out there because I mean, that continues to be sort of a thematic issue that is not as expensive to fix and address as some of these others. So you would think that we've solved all of the defense and death issues that we possibly could, but the answer is it doesn't seem to be the case. And so I think that's one. I mean, the other thing that we're struggling with a lot is, remote access. And so during COVID, but even before, the vendors and the government folks want to be able to provide remote software maintenance upgrades, from their house, from their company. And so that creates a lot of times an enduring, open back door, if you will. And so, I mean, that's another area that we're looking at, pretty hard. I mean, again, in terms of the network segmentation, we're looking a lot at software defined networking and how to use that as sort of a standard as we build out or upgrade, networks across an installation. Trying to formalize what the boundaries are. So, the Purdue model sort of creates this optimized vision where you have these different layers and things are segmented in a way they should be. And so again, some of that really basic enclaving, creating those boundaries so you don't have a boundaryless world. There's still work to do there, I would say, are sort of the big ones. I mean, sensing and monitoring, that's something we're more likely to do on things that are critical, but on the flip side, that can also create vulnerabilities. So that's kind of a tricky tightrope to walk.
Right.
I don't think that we'll ever be fully resourced to cyber harden every control system on our military base. I just don't think that. I mean, that's an amount of money that nobody as a taxpayer wants to, fund that bill.
I think everything has to be prioritized. I mean,
it has to be prioritized, and we have to.
For example, you want key buildings, for example, the Pentagon in this discussion, or you want the White House or other key buildings to be hardened, perhaps at 100%, from a cyber standpoint. But let me change gears just a smidgen. So, Paris, you have you wear different hats, and so one of the hats you wear is also an academic hat. So when you think about this for government, for institution, for commercial, how do they harden? What is the Sandy mentioned the Purdue model. I mean, do you think about those levels? The levels, I think it's 0 through 5 or 1 through 5, I forget now. Yeah.
0.
So if you think about that model and you think about whatever, like what is the approach that you're familiar with?
I love it. This is such a kind of germane discussion, and it actually aligns most with my background in industrial or systems engineering, right? Like to me, this is a process question, and we collectively as a community have to figure this process out, because our built environment is just growing and evolving at such a rapid pace.
Right.
So this is actually where the academic world and a lot of the researchers, have made some, I guess, what I would consider significant contributions. So again, I'll just restating basically what Louis and Sandy talked about. You asked the question, Ari, first of all, how do you stop attacks? And I think my first comment there is, and I think everyone on the call probably is in agreement, I don't think we're stopping attacks. In fact, I think it's the opposite. I think attacks are going to keep coming, and they're going to come at a more rapid and more sophisticated pace. I mean, that's a whole other conversation, right? But the attacks are coming. But the question is, how do we stop the penetration? How do we stop the impact? And that's where this process, I think, becomes really important. And so Sandy referenced, a defense in depth approach. I think that's something that, a lot of folks in the research community get behind, that there is no silver bullet here, right? This is a layered approach. We start with physical systems, so physical hardening that you mentioned, implementing security zones or access controls or air gapping first. Then, of course, we have the digital or cyber hardening that has to be done. And that's, again, Sandy mentioned implementation of things like zero trust and, firewalls and additional kind of digital barriers. And then there's the people, right? We can't forget how the people have to be a part of this system. So are they getting trained appropriately? Have we done appropriate, supply chain risk analysis, right? So this is a layered approach. And something that I don't think gets enough attention in that layered approach is the pregame, right, left of boom, and that is the design stage. And so something just for the awareness for the folks on the call, an area that is growing from preventative hardening standpoint is an idea called cyber-informed engineering. So I'm not sure if folks are tuned into that yet. Idaho National
and cyber
Labs.
commissioning.
Yes.
So please talk about that.
Well, I'll just highlight it, and others on the call I see nodding can speak to it. But to me, I think that's the future. That's where we're going. If we're going to really make a dent in this, is we have to move from reaction, and from this hardening, we have to move left and through the
whole cycle.
Exactly.
From design,
and build it into the design. That means our engineers need to be trained, everyone. Right. So I'll stop there. But to me, that's the major takeaway.
It's true, and we can even layer in some of the standards applied to those design assessments, those physical site assessments. But there's going to be some engineer or cyber engineer or OT cyber engineer of record on that design at some point, right? I think that's the vision of one of the people in our circle who served this country so honorably for years and decades. And I guess, Sandy, what comes to mind is, let's say you have two scenarios. One is a retrofit, and one is a new building. So if you can pick whatever one you want, but if you could, without mentioning details, could you talk about a project that's currently on your desk that you're thinking to yourself, wow, I want to just take what Paris said. I want to see this, for example, in a digital twin, or I want to see this, the BIM model at the very least, and I want to see kind of what's going to be attached to the network. And like, is there something going on where you're doing it that way, where you're trying to be proactive?
I mean, there actually is. I'm not going to take credit because the innovation's really happening out in the field. But I mean, we're definitely doing, I don't think it's a secret. We're doing a lot of new construction, greenfield work, if you would, in the Indo-Pacific area of responsibility, specifically in places like Guam. And so we have, within the military construction program, we developed over the last 7-8 years criteria that describes how we should design facility-related control systems into the military construction project from a cybersecurity standpoint, such that coming at the end of construction, you could cyber commission it and you would have all of the artifacts and drawings that then the government internally could use to go through a NIST-based process risk management framework and sort of be, yes, this building is secure and it can connect to the network that's running all of my control systems. So we have that out there. I mean, the folks in Guam have really cracked the code because they know firsthand that, you can have a hurricane and everything that you have can be lost. So they're taking the extra step to really ask for, sort of all of the right things at the beginning of the contract and to really do a vigorous commissioning process. And so I think that's really great. I think that the other thing they're doing, which is something that, intuitively, I think this is where we're headed, but it's kind of groundbreaking because we have not made this a requirement, is delivering important facilities, delivering critical infrastructure already equipped with its own sensing and monitoring cyber capabilities. Like typically that would be something we would add on after the fact, but why not have a complete and usable facility, purposely designed to have sensing and monitoring be built into that solution set. So to me, that's pretty innovative. And I think that's a good starting point for sort of raising the bar in what we ask for from our construction contractors, that, we're not just asking you to deliver us like bricks and mortar. I mean, maybe we were 50 years ago, but honest to God, you're delivering something that you're integrating with the systems of systems. And if you're not sort of meeting that requirement for us, and we're not asking for it in the right way, like help us out and help us figure out how to ask for and deliver what we want, would be my call to industry.
So mentor us. So Louis, when I think about this, whether it's greenfield or brownfield, so new site, retrofitting existing site, if you're able to, are you thinking, can you share any examples of people who are, if you're working with them on some power station or water treatment facility or maybe a hospital or something, that is viewed as critical infrastructure, are they doing it up front in the either retrofit or the actual initial design? Is anything come to mind?
So it's interesting, and I think that I'm going to extend your question by saying that we're dealing with entities in the public sector who don't typically have the luxury of a new building. They may, in one case, they have 1,000 buildings and they're building 2 new ones. So what 0.2% would that be it for the new equipment going in? I think somebody once said there's several 100,000 infrastructures in DoD. I'm not sure how many are being built on Guam, but if there was 100, the percentage over the 500,000 would be X. So I think the challenge is, and by the way, monthly there can be new sensors, and Ari, you and I have looked at a lot of really incredible things with cameras and AI's connected to everything, and on it goes, and et cetera, et cetera. So this is all great feedback, but what protects and stops an attack? And the problem is a little bit bigger, and this is something that we spend a lot of time focusing on in engineering, and that is that, and this is also a characteristic of OT, is that the concept of getting a system installed is one thing. How you manage it and manage it effectively is another. So I can put a device in that uses TLS, a protocol to protect it in a building, or put secure boot on a device so that I know when it turns on, it's my code. But 6 months later, there's another threat vector that you need to address. How do I do it? So we spend as much time developing technologies to protect things at the edge as the platform to manage it and update it. Because OT traditionally will install something in 30, 40 years, it's still on the wall, ceiling, or roof of a building running. We were on a DoD base with a decades old system they didn't want to touch. They weren't sure if they could put it back online if they did, but it ran. And I assure you, it has not seen a firmware update in decades. Whereas any of us who have these things called smartphones know that on a daily, weekly basis, there is an update. And to remain cyber resilient, it's probably something, and not resistant, but resilient, addressing the things that are coming, part of the infrastructure you need. And we find that lacking in a lot of places. So even if you get it right, you're doing the latest and greatest today, it doesn't count tomorrow. And one area, and I don't want to go down this road other than throw it out there, we're talking about all this cyber resiliency and all this code. We have already completed the initial pilot work for quantum resistant platforms. Why? Not because it's a threat today, but it's going to be a threat 2, 3, 5, 8 years, pick a number. That's not for me to say. And are you going to rip and replace everything? And we don't think so. So our work has been, so how do you upgrade from NIST's current legacy systems to post-quantum? So these are the sorts of things that we're trying to answer when you say, how do you put in something today and then maintain it? And I think that's part of the equation that's often missing when you ask for the latest and greatest, because you get it for today. And in the OT world, it's not going to be enough.
Sandra, a moment ago you mentioned NIST, and I want to open up a question to all of you. When you think about hardening critical infrastructure, what standards come to mind? That, for example, you're going to do a site assessment, whether it's at the front end of a design or you have an existing building and you're retrofitting and you want to know, what kind of like taking the temperature, like how vulnerable is it? So what standards come to mind to do those site assessments? Any of you can self-select.
Well, so I don't want to correct you, but I want to point out NIST, who is a critical guide for everything we do, provides guidelines. They are not standards. So you cannot take NIST 1800-53 as an example, which is a good one to look at for this, and go to a lab and be certified NIST compliant. ISO you can. So NIST issues guidelines, and then we all sort of respond with what we think are good. So I mentioned 800-53. 800-82, I think, is for industrial control security. So again, these are all good guidelines. And in fact, you can then, as we have done in some situations, then try to map your compliance to it. A NIST zero trust framework. Everybody, it's mandatory. I think it's on my children's school site, is NIST zero trust compliant. You can't get certified, but we all say we are. And as a matter of fact, I always go, well, is it NIST or the NSA? Because NSA is 7 pillars, NIST is 5 pillars. So are you a 5 or 7 pillar zero trust? So again, you have to be careful with these. There's recovery guidelines from NIST. I don't recall the numbers to it. There's industrial IoT. These are really critical to use.
I've also heard of building cybersecurity.org, right? They've tried to bring together these different standards into one framework. But let me, Paris, Sandy, any thoughts to add to Lewis?
62443 is what comes to mind in terms of life cycle management. And also, I know this doesn't quite apply, but the CMMC cybersecurity maturity model certification that DoD is requiring for manufacturers is now, as I understand it, starting to now incorporate some very OT specific requirements. Oh, they're not there yet. Maybe they're still under development. It was a gap early on when they were doing it, and I know the conversation's going on. So I don't know where they are in that. Sandy, sounds like you know.
It's certainly not in 2.0. there's a group of folks who thought it was. I mean, I recently pulled the thread on this because people were like, oh, we've got CMMC 2.0, like our lives are saved. And so I met with the people in DoD who are running CMMC 2.0 and found out exactly what it is and exactly what it isn't. And it's only focused on CUI data. That's all it ever was focused on. And I mean, focusing on OT is a completely different animal, completely different. And, I don't even know how they would go about doing it, because the ability to sort of like do this like third-party independent assessment of all these diverse control systems just seems like a bridge too far to me. I'm with you. I think, you got the NIST. So today in DoD, what we would do is we would look to the NIST, and then we would assess a system or a building or our processes or our people in the context of the risk management framework. And are you compliant? Again, does compliant mean cyber hardened? It does not. So I've been trying to push the last 2 years to look at the ISC 62433, because it does have standards and it does have performance requirements, and you can adjust it based on critical infrastructure. I'm kind of like the lone person saying that on a windy corner. It would be great if industry was excited and was like, yeah, she actually has a really good point. But right now I just feel like a crazy person when every time I say it at every conference. And I said it recently at a DoD CIO conference, and the DoD CIO met me after the conference to shake my hand and tell me to never say it again. So I'm saying it again, but I mean, I really think if that's what is the right answer, or certainly at least a step in the right direction, when you talk with, international communities, you talk with folks that are doing things with other parts of the country, they're not using NIST. The financial banking industry isn't doing RMF. So, for us to really leverage what industry is doing, we can't go off and have a whole set of like paperwork, bureaucracy, and compliance that doesn't resonate with what everybody else is doing.
I got it. So I'm sorry, did I interrupt someone's thought?
I was just going to foot stomp, what I felt like
Please.
this was a takeaway here, and something we struggled with when we were, when we are doing this research, which is, to me, this is an area of a gap, right? And Lewis mentioned it earlier, it's that IT-OT overlap, and you cannot apply IT rules to an OT environment. And, I think we've been waving our hands a little bit, but I think the time is now for us to really address that in some of these standards and guidance. And Ari, I was going to mention, from what I understand about the building security organization, I mean, that was something that I thought you all were making pretty good headway with. So maybe I've said too much, but I'll stop there.
No, it's fine. I think, for example, going back to DoD, I think that framework was applied by some of the people in that organization to one of the Air Force bases. And so if that's of interest to you, Sandy, offline,
I'm getting a copy of that report to see if it's something that's exportable, to see what we can do. But
right.
Yeah, I mean, a framework is good. A set using industry standards, to me, is better. And I mean, that's something that I think folks like CISA and others are in a position to do, because that would resonate more with the sectors that they manage. And so, if just DoD decides that's a good idea, that's probably not good enough. But if we could get
right. So there's something that comes to mind, which is probably important to all of us, which is cost and ROI. So I'll put this out in general to a question, but Lewis, I know you've done a lot of work looking at this on a per square foot basis per year, but if you take it, maybe give an example of a typical building, whether it's 5 stories or 40 stories, like what would it take to harden it in terms of, let's say, the added, maybe the metric is cost in US dollars per square foot per year, in terms of the occupancy cost. What would it add to it, A? And B, what do you think the ROI would be in terms of, business continuity or life saved or injuries prevented and things like that?
Great questions, hard answers. So most people we encounter go, yeah, building's protected, I have a firewall. And we smile and you're talking thousands, tens of thousands of dollars, maybe one-time fee in some sort of service and support contract. Um, Generally speaking, for new technologies, we see buildings acceptable in the 10 to 20 cents a square foot, to answer your square foot range, maybe a little bit higher, maybe into the mid 20s. So that's an annual. So it's adding 20, 25 cents. And again, sensitivities to that range from, oh my God, that's so expensive. I don't spend that much on cleaning my lobbies. And then I always go, okay,
Right.
so
As if that's apples to apples, right?
yeah, I'm trying to, and that was actually response in one case, and I'll go, okay, well, maybe we need to add that feature. Anyways, it's new enough that it's really hard. It looks like, and again, I'm on the East Coast, so we have a building in Manhattan, and in better days, an A building will get 70, 80, $90 a square foot. So adding 25 cents for the year, 2 cents a month was not seen as a hurdle. In other places, that's material. So that's sort of been arranged from an equipment perspective. They're depending on the wiring of the building and the networks, you could protect the building for $15,000, $20,000. It could take 75, 100,000. I'm thinking of a building in a place called Hudson Yards. It would probably be 250,000 because it's all very shiny new with lots of IP endpoints that are controlling critical features and functions. Now, this is a 60 plus story building, brand new in Hudson Yards. Trust me, it was probably a 8 or 9 figure part of their budget, so it's not a big thing. But that's the range of numbers you're looking at, subject to what your environment looks like.
Let's take that building, that shiny object at Hudson Yards. Let's say that they didn't do that improvement that you had been commissioned to do. I assumed you were commissioned to do because you bring it up as an example. What if they didn't and it was completely vulnerable? What would be the let's call it the estimated cost of that building being down for, I don't know, the elevators don't work, the access control doesn't work, people can't use things, so let's say it's down for a week. What does that mean?
So forgetting the elevators, even in access controls, the 2000 endpoints were airflow, air quality, environmental controls, all the other things that would make a building habitable in a 90 plus degree day in the summer in Manhattan, or in a 5-degree day in the winter in Manhattan. So, doing, and specifically numbers to that building, that was, again, going to be, someplace between 150, 200,000. The estimate to put that building back online, and this was the OEM who brought up the attack, figured it would be about an hour and a half for them to bring the building down and all the endpoints. They estimated about a month and a half and $6 million to put it back online, just that one time. But I think there's other examples. MGM Grand Hotels, I think, will tell you that their cyber attack last year cost them in excess of $200 million for a few days of being offline overall in terms of recovery in their systems. You can go back a decade ago to Target, who suffered an attack where they stole 30, 40 million credit cards through their HVAC system. Again, it was an open thing a vendor did, not so much a brilliant attack. Cost them $200 million plus. So these attacks can be pretty expensive, relative to, doing some of the mitigation that, both Paris and Sandy have referenced for a second.
Sure. Now, there are certain times a year where I might view Target as being critical infrastructure, like back to school, for example. But in general, it's not a water treatment facility. And so I guess Sandy or Paris, both of you, are you familiar with any kind of numbers on critical infrastructure, like cost to implement and ROI of implementing?
So, we've been looking at, so again, the control systems that are in my portfolio the way that we sustain infrastructure and buildings on our bases, we use a mathematical algorithm, and it actually equates to a cost per square footage. And it breaks it down into different categories of buildings. And so there's a cost per square footage for a shipyard, vice an administrative building, vice a queue where people are going to be like living and working. And so we did some initial work with the Navy. I'm not going to use exact numbers, and I don't think it takes into account all of the costs that Lewis mentioned, but we were just looking at, if you take something like a fire alarm system and you cyber harden it, and you already have fully funded the CIO people that are going to give the cyber hardening oversight, care and feeding, they're already like funded separately, then what is it just within your sustainment, your cost per square foot that you need to be thinking about, because you need to do some kind of hardware or software refresh in order to keep something cyber hardened that typically we wouldn't do. We just wouldn't do it. We just like, it's running, it's not broken, we're not going to refresh. And so adding this new requirement and just the sustainment cost of that on a subset of not our most important buildings is like probably going to be in the magnitude of hundreds of millions of dollars per service. So it's real money. And maybe in part that highlights the fact that we weren't doing what other people might do in terms of sustainment anyway. But I mean, that's the real world we're in, is that we just run things until they fail, and we really don't do that sustainment work. So it's not an insignificant cost. Again, is it worth it? I think it is, but it's hard to demonstrate the way that industry does. What is that cost of downtime? Because it's different communities that are impacted. So, the people who are the most impacted, it's really hard to get to them to say, like, what does this really mean in terms of workarounds that are so costly?
You'd have to look at all the failure modes and what's the impact of failure. And so in terms of cycle time on whatever task that it's needed for a mission, and also the replacement time, labor and materials to get it done. So you'd have to look at that. But
I was going to ask Lewis. I mean, so industry had this event, and they spent money to get themselves back to where they were. But the folks that had this experience, are they now investing at a different level as well? It was like a lesson learned, and they've like actually changed their behavior, or are they really just, we fixed the problem and we're kind of back to operating the way we were? What are you seeing industry do?
So right now, it is changing in a positive sense, but right now I will tell you, generally speaking, it's back to the way they were, because what you have is a lot of this, you have a siloed scenario, less siloed now, but in even a few years ago, you'd go in to install building controls or what have you, which have been networked for decades, the way an IT network is networked. And yet when you reach out to the IT folks and say, hey, the building guys are putting in a chiller, we need you. And there's like, we don't do chillers, etc. And it's the same thing a little bit in the response, in that, we need a better, faster, shinier tool that can identify anomalies. Okay, now we can use AI, and I've got this great network tool that I'm going to bring in to identify anomalies using AI. So very, very long-winded way of saying, still a very strong IT centric, I don't use the word myopic, but an IT focus, not thinking about the cyber physical. So they just go, well, we need a better firewall, a better what have you. And if you look at the increase in cyber attacks, we know those things aren't working. They help. There would be much more damage. But the response, because there's still a learning curve, and it's, and they're fighting their own fires. So it's hard to get attention sometimes in these places to see what other solutions are. And there are a number of them, including ours, but there are a number of them out there that you don't see those people at building events learning about cybersecurity. We were at the nation's largest controls building event, 40, 50,000 attendees. There were 2 vendors, us and another one with cybersecurity solutions, with 50, 60,000 attendees. And several thousand booths, by the way, several thousand people in booths, to give you an idea of how the industry is currently bringing itself up to speed.
Any thoughts, Paris?
Only just to say, in my understanding, it's also real industry specific or sector specific as well. So, if we think about, like we said originally, critical infrastructure is a lot of things, right? It's everything from hospital systems, including manufacturing. And so these costs, I think, are going to be different, as Sandy was indicating, depending on who it's impacting. When we were working in the manufacturing space and kind of looking at this question, Ari, it was actually an impetus for a lot of the research that Symantec is doing. We looked at issues like downtime, which was already mentioned. So manufacturers experience downtime at, on average, something like 300,000 per hour. Right. So you just extrapolate from there. That's what an hour costs a manufacturer. Recuperation time, I think IBM X-Force report, if anybody follows that, they put one out every year. I think there's something around like $4.5 million for recovery costs for on average for a cyber attack.
Wow.
So
look
you
at
start
the ROI on that. It's much greater than one. Going back to Lewis's number.
Oh, for sure. Yeah. And
Wow.
If anybody is pressed to, have these conversations, there are individual studies done. We did a study on a natural gas, I think it was a cracking process, where we said, we're taking this process and we're going to digitize it, right? We're going to help this process become more efficient and save time, money through industrial controls being applied. In doing so, you also open up the system to potential vulnerabilities. So what's the cost savings of that? And I think the overall model produced a cost savings of about 12%. So again, that's a sector within critical infrastructure.
You were so ahead of your time. I would welcome you sharing that to the group. Before we run out of time here, there's a question from the audience. And Sandy, you're taking the most interest, it seems, in this question. Do you want to address it?
I could go on for an hour on this question. I mean, I think there are lessons to learn. There's also still so much work to be done, and I really do feel like there's a lot of people that don't understand when you create a cyber physical event or attack, that there really can be life, health, and safety impacts. I think there's a lot of folks out there that and I know this from going out and doing cyber exercises recently at our installations, that they just think they're going to see a blue screen, or they're going to have some kind of IT, it's not a big deal activity. And so, I mean, there is a stringent safety, but I don't know that all of this is really cross-pollinated into the world of cyber physical as much as it could. I think the good news is we have some opportunities to try and get it right across the national sectors. There's a new executive order that came out on the 19th of March that's really talking about, let me see, achieving efficiency through state and local proponents, but it's really talking about how do we all work together, which would include the national critical infrastructure, to really develop a national resiliency plan. And so I think that's an opportunity to really come together, because it's all about what are the interconnections, what are the interdependencies, and how do we prioritize and address those. And so I think between that and the national sector memo that came out 22 last year, there's a way to take, those methodologies and that established thinking that's sort of in a nuclear or the civil works that's running the dams and levees, those communities, and then really flow down those best practices focused on cyber physical vulnerabilities.
Well, you got the last word.
Oh, no.
With all respect to Paris and Lewis, I want to thank you all for your participation on this webinar. Next month on April 18th, Friday, April 18th at 1 p.m. Eastern, we'll talk about on the environmental, health, safety, and financial benefits of optimized indoor-outdoor airflow management, which is, it's not exactly, let's call it a first cousin, but it's a third cousin, because when you do those kinds of implementations, speaking to Paris's study, you do open up vulnerabilities. So I think that's kind of my tie-in that way. But again, thank you. and I'm applauding you in my mind. And I can speak for me, but probably for everybody, which is we all came away inspired from your insights and your experiences. So thank you.
Thank you for having us,
Thank
Ari.
you.
And great to
You're
see
welcome.
everybody.
You're welcome. You're welcome.
Thank you.
Bye for now.